Okay, kitty, let's go. Don't call me a kitty. I'm a man. I'm a man's man. I'm a lady. I need help. I'm just kidding. Let's get going. Okay, look. Seriously, if you haven't done part one, hopefully you've done part one, and then you already know that we have these posted online. So if you've just gotten here by accident and you haven't seen the first one, first things first, you ought to download these. Try these on your own. The easiest way to go is to go to nkinfinity.com. Click over here. Click underneath New York State Teachers, and then click on Regents Review. And in there you'll find, here's the test. Here's the answer key. Try the problems on your own. Do the problems on your own. And then come here if you don't know what's going on. But we've already done the first 12. So we're going to go down. We're going to do 13 through 24. Now let me get this thing widened out a little bit. Ooh, that's not good. I want it bigger, not smaller. All right, so let's see. I got to keep my big head out of the way, though. So this is a weird problem. I don't know why it started like this, I guess. So anyway, Snapdragon ride at the Darien Lake, that's a local park around here for those of you that don't know, moves from its central position at a rest according to this function. Blah, 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 where t represents time in seconds, and blah, blah. What is the ride's maximum height? Now, remember, kids, in a sine curve, a sine curve can go up like this and back down, right? And this is its maximum height here. Now, in this particular case, because we're starting with a negative, right, that negative 100, that just means the sine curve is going down first. Apparently, this curve goes into the ground, I guess, before it does anything else, but whatever. So it goes down first, and then it goes up. Now, it doesn't, in this case, it's not going up from the x-axis. This is not the x-axis. So now what we got to do is we got to think about what's going on with this curve. All right? So that's just a brief look at the sine curve. So if this was my x-axis, and this is my y-axis, this is my starting point. This is what we like to call our midline, 20. There's my midline of 20. Now, because I have a negative, I'm still coming down first. I'm going to go down 100, so it's going to go down here, and then it's going to go up 100 and up, down, and back down. Well, if this is 20, and this is my amplitude, it's going up 100 and down 100. That means my maximum height is starting at 20 and going up 100 feet. So it looks like 120 is my maximum. Oh, got it right here in my hand. Now I got to get rid of this stuff. All right. Long division. Again, I'll show you how to cheat on this problem just because that's what I like to do. Anyway, wow, we got some division to do. So what we're going to do is we're going to start with our long divisions. We're going to 2x plus 3, and we're going to divide it into 6x cubed plus 17x squared plus 10x plus 2. I think you can cheat in this problem. I'm not really sure. You got to see what can I do to this to make it look like this. Multiplying, and I can multiply by 3x squared. Now remember, you're going to multiply by both of these. So that gives me 6x cubed plus 9x squared. Don't forget, this is the hard part. This is the one part everybody forgets. We're going to subtract here. Subtract, you got to give that subtraction to both of those. Whoosh, whoosh, those go away, and I end up here with 8x squared. And then copy everything else down. I do. So how many of them start out with 3x squared? Already down to 2 answers. Already down to 2 answers. That's good. So what am I going to have to do to 2x to make it 8x squared? Oh, I'm going to have to multiply by 4x. Well, now I already know this is my answer. At least it appears to be my answer. I'm still going to check my work, right? So we got 8x squared, and 4x times 3 is plus 12x. Don't forget, we're doing a little subtraction here. Subtract. I get negative 2x plus 2. So how can I make positive 2 into a negative 2? Multiplying by negative 1. There's a negative 1. So I get negative 2x minus 3. This gives me, and don't forget, we're going to subtract. Here comes the hard part. Subtract, changes this to a plus, changes this to a plus, and makes this 5. So divided by this, 3x squared plus 4x minus 1, but because it's a positive, plus 5 over 2x plus 3. And that's that answer. Now, I wonder if there's a way to cheat. I think there is. So let's do this. Let's take 2.36 and store it in x. I always just pick a random crazy number unless I'm using, unless I have to use the answers that are in the actual answer key. All right, so I'm going to look down at my sheet here. It's control division. And it's 6x cubed plus 17x squared plus 17x squared plus 10x plus 2 all over 2x plus 3. 2x plus 3. Hit enter. Some obnoxious number. Now I'm going to type in my answer. 3x squared plus 4x. I hope this turns out to be the same. Plus 4x minus 1 plus, now we got to do control division again, 5 over 2x plus 3. Did I even need to do long division? Are you kidding me, Krause? Oh my God, that was so much easier. Thank you. Try the problem on your own. You should be able to do it the other way as well, children. It's my stern lecture. Alrighty then. What are we doing? I think I went too far. There we go. Which statement represents exponential decay? Now, I will tell you the easiest way to do this problem is just to graph them. If you graph them, this one will graph to, this one will graph to this. This one will graph to this. And then it appears as if one of these is the right answer. But let me explain why they are. Normally a decay question, however it looks, y equals some starting amount. And in this case, it's nothing. And then this should be less than 1. So most kids, when they remember that, are going to go, oh, this is the right answer. But it's not. It's not the right answer because it's 1/5 to the negative x. And this negative says to take this fraction and actually flip it. So this becomes 5 over 1 to the positive x. And that's exponential growth. This one then is also to the negative x. So that's going to take that 5 and make it 1/5 to the positive x. Now I said the easiest way to do is just simply graph these suckers, right? Let me graph both of those. So the first one was 1 divided by 5 raised to the negative x. And I graphed that, and that's an exponential growth question all day long. But if I do the second one, which I'm going to do in probably red here, that's 5, not let me, 5 raised to the negative x. And you'll see the red one is going to be in an exponential decay question. So like I said, the easiest way to do those is to graph them and see which one comes down, but you should know what's going on. A circle centered at the origin has a radius of 13 units. The terminal side of theta intercepts the circle in quadrant 3 at point P. The x-coordinate of P is 5. Find the sine of theta. Holy son of a... Well, okay, we got a couple things. One is we're in quadrant 3. And if you remember, all students take calculus, or however you remember it. Sine is only positive here and here. So I know sine is negative in that quadrant. So at least I can get rid of that one based on that information. So my angle, what it says is my angle terminates in quadrant 3. Something like that. My angle terminates in quadrant 3. My radius is 30. Maybe it would be better if I actually draw what's going on here. There's my axes. Let me change colors. There's a circle centered here. Its radius is 13. Okay, that's what it said. Its radius is 13. And it intercepts this arc in the third quadrant. And we got to figure out what this angle measure is. Well, okay, if you remember correctly, anytime you're doing this, we're going to create a right triangle here. And it said the x value of this point the x value of that point is 5. Excuse me, negative 5. So I know we came out negative 5 here. I really got to find this value right here, so I'm going to call it x. X squared plus negative 5 squared equals 13 squared. You got to do the Pythagorean theorem. I hope by now, if you're in trig, you should know that's a 12. I'm actually not going to go through this math. X equals 12. I'm assuming you guys can do the Pythagorean theorem. You know, you move that over and you do that. So I get x equals 12, but since it's down here in the third quadrant, it's really negative 12. Since we're coming down. That's a directed distance down. All right, so what is sine? Well, sine is, theta is opposite over hypotenuse. So the opposite is negative 12, the hypotenuse is 13, and there is my answer right there. So I just got home. And I got a message from a kid that said this problem was done wrong, so that's why I look like a bum, and I'm here to fix it. So I want to fix it for you, so let's talk about this problem. Let's see if I got anything graphed. First thing I'd probably do with this one is just graph this question. Come in here, graph this, y equals 6 to the x. Thank you to that person, I forgot your name, that told me this was wrong and helped me realize. And you know the funny thing is, I did this in class today, and I almost got it wrong in class. I don't know what's wrong with me today. It's been really crazy lately. So anyway, we're looking for the one that's false. False. So what we're going to do is we're going to graph this thing. Let me show you what it looks like real quick. You just graph 6 raised to the x. It's a very steep exponential curve. So we're looking for the one that is not true. So let me sketch this one. It looks like this. Goes to the point 0, and goes really steep up. Now, looking at it here, it looks like it hits the x-axis. It does not hit the x-axis. Never, 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 never. I even pointed that out and then still got it wrong. See, I can go there all day long. It never hits the x-axis, ever. It looks like it does. See, it looks like it hits it. Doesn't hit it. So, what the question says is, which of these is false? The asymptote has an equation that's x equals 0. Well, x equals 0 is this line right here. That's the line x equals 0. X equals 0. This is the line y equals 0. This one is the asymptote. This one is not the asymptote. So the asymptote has an equation 0, x equals 0. That's not true. This graph has no x-intercepts. That's true. This purple line never hits the x-axis. So that is, in fact, a true statement. I think in the video on the one I did the first time, it said that was true. The domain is the set of all reals. Does it go forever and ever left? Yep. Does it go forever and ever right? Yep. So the domain is the set of all reals. That is true. The range is the set of all positive integers. Positive integers just means greater than or equal to 0. So is y greater than or equal to 0? Well, if you graph this thing, it goes like this. It goes up. But remember, it never touches that x-axis. So it gets really, 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 really close to 0, but never touches it. So that is also, in fact, a true statement. So my answer is choice 1, because this is false. False. All right, sorry about that for making that mistake. There's the end. All right, moving on. The equation blah, 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 blah is equivalent to, holy crap. Are they crazy? All right, wow. I could double distribute all this out and figure out what's going on. Or I could take this thing, and I'm going to take a 6 out of all this. Notice I can take a 6 out. I'm going to take a 6 out. And I'm left with x squared plus 2x. I'm going to leave a blank. You'll see why in a minute. Plus y squared minus 8y plus a blank equals 48. Now, I only took a 6 out of the left side. Let's do this. No, let's not do this. Okay. So here's the hard part about this. This problem's nasty. Nasty little problem. I'm going to show you a way to cheat, of course. Why wouldn't I? No, actually, I can't. Maybe there is, but I don't care. I'm going to figure out what goes in this box and what goes in this box. But because of that, we're going to have to add 2 things over here, and that actually is going to be the hard part. This is going to be x plus 1 squared. So a 1 goes here. Now, normally you would put a 1 here, but that 1 is actually multiplied by that 6. So really I got to put a 6 over there. And that's kind of the tricky part. Plus, this is y minus 4 squared. So normally I'd put a 16 here, but that 16 is multiplied by that 6. So I got to do 6 times 16 equals, now 6 times 16, what is that? 96. 102, that's 150. Now, notice there's 150 over here, so that's probably, oh, this isn't that bad because they're all 150, so that actually doesn't come into play because those are all 150. So even if you had messed that up, you still should have gotten to this point, and your answer is choice 1. Moving on, kids, moving on. All right, which statement about the function graph below is, oh, Mr. New York State likes Mr. Incorrect. Oh my God, so much fun. The degree of this polynomial is even. Well, that's the answer right there. I'm just going to tell you right now. An even function is like a parabola. It goes up or down. It's either going to be both up or both down. An odd function goes up and down in opposite directions. So that's the answer. That's the answer to that question. There is a negative leading coefficient. Well, notice if I just drew this straight line in here, that would have a negative slope. Yes, it has a negative leading coefficient. There is a relative maximum. Yeah, there is. There's a relative maximum right there. There's also a relative minimum right there. There are 2 intervals where the function is decreasing. Sure, it's decreasing from negative infinity to right about there. And it's decreasing from there to positive infinity. So that one doesn't work and that one doesn't work. But the thing is, you have to remember, an even functions either both point up or both point down. Odd functions go in opposite directions. Okay? Only a few questions left. So if you missed this one, it's because you didn't pay attention to detail. Detail. Everything about Algebra 2 exams is all about the reading and understanding what's going on in the problem. Yes, there is a 3.6% growth rate. Yes, that is 0.036 growth. So anytime we have growth, we've got some starting value, 1 plus the rate, in this case 0.036, to the exponent. Now, what the exponent looks like is a little bit different. What's this rate look like is a little bit different depending on the problem. In this case, this is 3.6 per year, right? That's a 3.6% rate per year. I'm not asking about per year. I'm asking about monthly, and X represents the number of months, not years, months. So if I want to know what my monthly increase rate, I can't use a yearly interest rate to find out what's going on monthly. So this is the trick to this problem. You had to take this and divide it by 12. I meant 12. So if you didn't divide it by 12, no. So that's the trick. Had to make sure you divide it by 12. Because again, this is the monthly interest rate. You know, so don't fall in that trick. Oh, I just add 0.036. Oh, got it. No. And X is in the number of months. I think if X is in the number of years, this would be the right answer. But this is the correct choice for this problem. All right, kids. That's it for number 20. Wow. Okay, so this is Y. So I'm just going to plug that in for Y. So I get 13 over X plus X equals 10. Now, in order to get rid of this X down here, well, I'm just going to multiply both sides by X. Now, by doing that, if I distribute here, I get 13. If I distribute here, I get X squared equals 10X. Now, whatever you multiply one side by, you got to multiply by the other. I'm going to bring this 10X over, so I get X squared minus 10X plus 13 equals 0. Wow. That's not nice. By the way, I'm going to do this 2 different ways. I guess I'll do quadratic formula. I'm going to do completing the square. X squared minus 10x plus square equals negative 13 plus square. This is not, by the way, how I would do this problem if I was doing it on my own. I'll show you in a second how I do that. This gives me x plus, x minus 5. Why is it minus 5? It's half of whatever that is, squared. Well, if I square that, I get 25, and I'm going to put a 25 over here. So this equals, what, 12? So x minus 5 equals plus or minus the square root of 12. Because remember, you got to come through and take the square root of both sides. And when you take the square root, don't forget to put a plus or minus. And then this 5 comes here and goes right in the middle. So if I go to my calculator and I go 5 plus the square root of 12, that's one of my answers. And that's my other. 1.535 and 1.46. Or 8.4. Whoa, we got some issues here, kids. Round to the nearest tenth. Oh, didn't she fix these? Oh. Wow. This was a nasty problem. So, okay. So I get x equals, let me write these down, 1.535. And x equals 8.464. 464. Wow, she was not nice. So round to the nearest tenth, this is 1.5. Round this one to the nearest tenth, it's 8.5. So this is the only acceptable answer. Wow. You might think, oh, crazy thinking about that question, because you might think it's 8.4, but it's not. It's really 8.5. How would you do this problem graphically? Well, okay, here's how it looks graphically. We're going to graph the first one, which was what? 13 over x. 13 divided by x. Enter. So that's that funky machine. And then we're going to graph the other one, which is simply, now the other one I got to move the x over, so it's negative x plus 10. So tab negative x plus 10. Enter. And so you see where we got the two answers here? They're the two answers. So I could just simply, I graphed them. Now I just got to find their points of intersection. Menu, analyze the graph, intersection, click. 1.54, and then menu, analyze the graph, intersection, click, 8.46. So you just got to be careful with the rounding here. So I didn't really necessarily need to go through all that math. I could have just used the calculator. Now I'm not really sure what it is about this word right here that causes kids to just freak the heck out. You're just freaking out. Crazy. Recursion is just a sub 1, a sub 2, a sub 3. Recursion just says, okay, start with an initial value. In this case, my initial value is 1. One wheel or one circle or whatever the heck that thing is. And then the second one or every other one after that says, what did you do to the previous term? Sometimes it's the previous two terms. But what did you do? Oh, I multiplied by 2. Oh, I multiplied by 2. Oh, I multiplied by 2. So what did I do? I took 2 and I multiplied it by the previous term. Well, the previous term is always a sub n minus 1. Well, they use C, but that's my answer. Straightforward, kids. There it is. Which two functions are inverses of each other? Remember, if they are inverses of each other, they are reflections. There are mirror reflections over the line y equals x. So cosine and sine, this is sine, and then this is cosine. Those are not reflections over the line y equals x. That ain't going to happen. This second one I'm not so sure about. So let's graph these. Actually, I am sure about it, but you may not be. So let's get out of this. Nope. And so graph again, and it is 3 plus 8x. So 3 plus 8x. Enter. And then 3 minus 8x. Tab. 3 minus 8x. Enter. And you know what? Let me graph the line y equals x. Tab x. There's the line y equals x. Are those reflections over the line y equals x? Clearly not. So tab, tab. Let's get rid of them. Oops. And let's get rid of that one. And let's do the next one. E to the x. By the way, this is the right answer. E to the x. There's the e function. That's the exponential growth function. And you should know what the linear function looks like. It's ln of x. And there they are. Those are the mirror reflections of each other over the line y equals x. It's as simple as that. Now, whether or not you knew those were inverses of each other or not. Now, if I did the last one, they wouldn't be. Another test for this, by the way, is to show that f of g of x is simply equal to x. Oh. So I could do f of ln, of ln of x is equal to x. But f of ln of x, and this one's a little bit tricky. Well, you may not know this. E to the ln of x, well, that is equal to x. But in this case, that may not be a great way to do that one. All right, let's take a look at this one. First things first, whenever you want to figure out what kind of graph is being graphed, you have to find the midline. The midline is always halfway between the peaks. So that's 2, and that's 15. Oh, that's 8. Let's see. 8 minus 2 is 6. Divided by 2 is 3. So if I go down 3, I can find the midline. So the midline, remember, always goes at the end. That's a plus 5. How many of them have plus 5? Only 2. I'm starting down, so it's negative 3. Oh, done. Problem's over with. There it is. Because I started down here, not up here. I started down. Because I started down there, that is an immediate reflection, and therefore it is a negative in front. And there's my answer. Oh, that's it. That's the end of multiple choice. Oh my gosh, that wasn't so bad. All right, kids. Part 2, 3, 4 coming up. Those are the hard ones. I think the multiple choice are the hard ones because they're really easy to pick the wrong answer. Hit subscribe, hit like, keep checking NK Infinity for more review, and don't give up. Keep working hard. All right, kids. Catch y'all on the flip side. Goodbye.